Let's discuss derating conductors. When determining the appropriate size of electrical conductors, it's crucial to account for factors that can reduce their ampacity, which is the maximum current a conductor can carry safely. Two key considerations are the number of conductors bundled together and the ambient temperature in which they operate. When multiple current-carrying conductors are grouped in a raceway, cable, or bundle, the heat generated by each conductor can raise the overall temperature, reducing the heat dissipation capability of each individual conductor. This is why derating for the number of conductors is necessary. The National Electrical Code, or NEC, provides tables that specify the ampacity adjustment factors based on the number of current-carrying conductors in a raceway or cable. Similarly, the ambient temperature affects a conductor's ability to dissipate heat. Higher ambient temperatures reduce the temperature difference between the conductor and its surroundings, thus diminishing its cooling capacity. The NEC provides correction factors to adjust the ampacity based on the ambient temperature. You are correct in your understanding that you apply both the conductor derating and ambient temperature derating to the initial ampacity of the wire. This is not a triple derating as you describe. So first you would derate for the number of conductors, then you would derate for the ambient temperature, or vice versa. It makes no difference in the order you perform it. Now consider the case of a continuous load. According to the NEC, a continuous load is defined as a load where the maximum current is expected to continue for 3 hours or more. For continuous loads, the NEC requires that the overcurrent protection device, such as a circuit breaker or fuse, be rated at no less than 125% of the continuous load, or conversely, the conductors be rated to handle 125% of the continuous load, effectively limiting the load to 80% of the conductor's ampacity. This requirement is in place because continuous loads generate heat for extended periods, and exceeding 80% of a conductor's ampacity can lead to overheating and potential safety hazards. You are also correct in your understanding that you do not triple derate the wires. Instead, the NEC mandates a comparison between the ampacity of the conductor after derating for the number of conductors and ambient temperature, and the ampacity required to handle 125% of the continuous load. The most stringent of these two requirements determines the minimum allowable conductor size. For example, let's say we have a raceway with 3 conductors operating at an ambient temperature of 40 degrees Celsius. A continuous load of 20 amps is applied. Let's assume that the conductors initially have an ampacity of 25 amps before any derating is applied. After applying the derating factors for the number of conductors and the ambient temperature, the conductor's ampacity is reduced to 22 amps. Now consider the continuous load requirement. 125% of the 20 amp continuous load is 25 amps. Therefore, you would need to use a larger conductor with an initial ampacity that, when derated for both the number of conductors and ambient temperature, results in a final ampacity of at least 25 amps to safely handle the load. The key takeaway is that you're not derating 3 times. You're applying 2 derating factors, one for conductor bundling and ambient temperature, and another consideration of a continuous load at 125%, and then selecting the more conservative result for conductor sizing.